Manage mentoring for getting started in beekeeping. This is why hives die in winter. I am Kevin England. In this lesson, we will examine some of the more common possibilities that result in the collapse and death of a honeybee colony. I will run through the outline of plausible reasons, spending some time to emphasize the role that Varroa often plays in the demise of honeybee colonies. Experiencing that single moment when it becomes clear that the colony that you've been caring for has perished is one of the most disheartening aspects of beekeeping. At its core, the death of the animal, or in the case of honeybees, the superorganism, is a biological event that can occur for many reasons. This is the first of a series of lessons that examines the demise of a honeybee colony and walks you through the steps of using the loss as an important learning tool and understanding how to keep bees alive. In time, we'll discuss the steps to perform a necropsy, but first, this lesson focuses on the fundamentals of how a colony dies. To get us started, this is a simplified list of potential reasons or external factors that can contribute to the demise of a honeybee colony. We will expand on each of these elements and more as we walk through the lesson. There's a well-known adage in beekeeping that says if a colony has died, that Varroa mites were behind it. This is raised as the first consideration, as the fact of the matter is, while that's a very broad declaration in scope, in more instances than not, it's actually a good prediction. The items listed on the slide are often on full display. If you could examine each individual bee, you could figure out what contributed to the collapse of the colony. For a honeybee colony to overwinter as a superorganism, there must be a commensurate collection of healthy bees. There could be no worse case scenario than to inflict damage to the colony population during the period when honeybees are developing for winter, especially when the population being impacted will serve to support the winter cluster. Bees inflicted with damage during that development window are compromised, and sick bees do not function well enough to persist into spring. Systematically, it is also a multi-pronged failure in that within this window, inflicted nurse bees pass on harm to the developing bees. One unseen dynamic of attrition in fall is that some older bees end up persisting in the colony population because they have no choice but to serve the colony, and they are simply not suited to make it all the way to spring due to their age. As you take in this slide, recognize that there are many factors at play. And there are other reasons, and in the next few slides, we'll talk about other dynamics at play. In practice, honeybees are tropical insects, but over millennia, they have developed to withstand long exposure to cold temperatures. Honeybees, when properly situated, do not die from exposure, as they have the means to maintain warmth to survive long periods through the winter. There are, of course, limits to the amount of exposure that they can cope with, but we generally do not have sustained brutal cold to which your bees will be overwhelmed. It is true to say that some sustained severe cold weather can be hard on a colony, and especially stressful if the colony was diminutive and struggled to provide enough heat. This is why it's important to give the bees the best chance by bringing them through winter with a strong, healthy colony. When you provide a suitable hive configuration for the colony to reside in, a robust colony will self-manage the moisture present in the hive environment throughout the swings of conditional changes in winter. It is well known, though, that if something's out of balance and moisture problems occur, wet bees perish rapidly. The best offense to this is a large, strong colony placed in a properly configured hive, especially one that is suitable to the size of the colony going into winter. Of course, it's up to the beekeeper to ensure that the hive configuration is buttoned up And said differently, that means no errant moisture can get into the interior of the hive space to impact the bees at any time. This was touched upon a little earlier, but we'll explore it here biologically. If an individual bee drops below the temperature of around 45 degrees Fahrenheit, then they're subject to the inability to operate. And pragmatically, that may mean they're going to physically fall off the cluster to their death. If a colony suffers enough attrition over time, they will lose elasticity for the cluster to traverse the environment to get back and forth to the resources. Another unrelated biological event is the unfortunate failure of the colony queen. It is plausible occurrence during winter, but realistically, it's not something that occurs very often. Honeybees spend much of their time in a state of torpor, which you can think of as a dormant period or low activity. Of course, they have to wake up periodically and require consumption of food to persist till spring. If there's not enough food to go around, or if something is compromised with the food reserves that they have, say unripened nectar or wet sugar solutions, then maybe it led to that food fermenting while in storage. This type of condition can cause stress and illness to the bees. Additionally, it could be pointed out that some nectars collected by bees may have the characteristic of a high ash content, which bees really don't overwinter well on because it can lead to gastric distress. In some regions where it's known that fall forage provides high ash content nectar, beekeepers may change the colony's behavior by feeding them sugar solutions so they don't store that nectar. Now, this is generally not a problem in the mid-Atlantic region, but the truth is, it's dependent upon what your bees foraged on in the fall. Often attacks by pests and predators of honeybee colonies can lead to their demise. Predators, often in search of food, can inflict catastrophic damage while a colony is in an overwintering state. Sometimes, though, there's an unseen damage inflicted on the colony which fends off some sort of attack that compromised the colony population going in. You may never have been aware that your colony was under assault by wasps or opportunistic honeybees that attempted to rob the resources. They've had some material impact to the colony population, and that might be a contributing factor to the overwintering ability of your colony. The last one to explore is a rather obvious one. This is failure of the hive envelope in some manner. It could be from a configuration problem, it could be from equipment failure, it could be from interference from an external source, such as the example of a deer knocking over a hive. One problem that we discuss in overwintering guidance is setting up the hive configuration commensurate to the size of the colony. Some colonies exhibit stress because the space they are occupying is too large and it creates some sort of environmental problem. Heat dissipation, CO2 levels being off, moisture problems, and the myriad of other things can tie back to improper hive configurations. It is important to recognize the phenomenon of honeybees changing their physical makeup to an overwintering state. Biologically, honeybees that develop during the window where the colony is preparing for overwintering in temperate climates adjust their physical development to make them more suitable to overwinter. If during this period individual bees are compromised in some way, this has quite an impact on the survivability of the colony. After running down all the plausible possibilities for conditions that can compromise or outright kill the population of the colony, it's important to come back to center and say out loud that Varroa mites are an extremely likely underlying reason for contribution to colony death. The principle of Occam's razor is in play. as the simplest answer is often the likeliest answer. In the next few slides, we will unpack how the damage inflicted by Varroa can manifest when you examine the evidence after a colony has perished. Start at the photo, you will see that a queen is in the center and that she has perished. You can just catch a glimpse of the white marking on her thorax. This is a very typical image of what you might find. Bees that hung on the longest will be nestled around the queen and appear frozen in time. A Varroa mite impacted colony suffers attrition, and as winter marches on, the colony bees will dwindle to a state where the bees will die of starvation and exposure. It could be noted from the image that there are honey reserves nearby, but because the colony has dwindled to an insufficient population, they're not able to traverse the face of the honeycomb to get to the food resources. One very observable sign of Varroa mite infestation is the presence of mite frass. It can be seen in this image as the remnants of fecal material left behind from the Varroa mite presence. It's easy to spot as it shows up as white specks deposited in the honeycomb. Quite easy to see during an autopsy inspection. Simply pull the brood frames from the hive body, hold them out in front of you, and tilt the top of the frame away from you so that you can see the roof of the cells. A possible indicator of a colony dealing with Varroa mite impacts is remnants of an unhealthy brood pattern. Take in the scattered brood appearance and look for other telltale signs, such as puncture holes in the cappings, sunken cappings, and dead undeveloped larvae within the cells. Poor brood patterns are telling impacts of Varroa mites. It can be indicative of unhealthy bees in development and nurse bees that were compromised during the time when the colony was rearing the winter population. As noted earlier, a colony that perishes during winter often appears to be frozen in time. In a twist of fate, it's common for beekeepers to find dead Varroa mites in and amongst the bees. In this photo, you can actually see one visible in plain sight. It's advisable to make enough time to visibly inspect individual bees as you're going through your colony. You want to determine if there's any presence of Varroa mites on the actual bees. Additionally, you could use a toothpick or some other instrument to pull the cappings. Look at any of the bees that have not emerged and see if the state of the bee in development was compromised, along with inspecting the cell for the presence of any Varroa mites that had perished during the demise of the colony. Way through, you will likely find a large quantity of dead bees collected under the frames and on the bottom board. These are the bees that likely perished during the winter months and fell off the cluster because they were compromised and not capable of making it to spring. And within the collection of dead bees, you find additional evidence of Varroa mites. You can actually sample these dead bees and perform an alcohol wash to learn how prevalent the Varroa mites are in that collection that perished and fell to the bottom board. Also take time to move aside any of the debris and look for dead Varroa mites on the bottom board if you have a solid bottom board. Chances are you're going to find quite a few of them dead and perished on the bottom board along with the bees. There's one rather unusual sign of a colony that perishes from Varroa infestations. It's an abundance of stored resources. In short, the sick bees do not operate long enough or well enough over the winter months to draw down the reserves of food, and it's not uncommon to find a colony loaded with capped honey and other resources. In this lesson, we explored the physical reasons behind the death of bees in a colony that perished over winter. This will give us a jump-off point for what to look for when performing a hive autopsy. In the next lesson, we will describe the physical instructions for how to conduct a hive autopsy from the outside of the hive and all the way through the hive configuration. The lesson to follow that will turn the corner on how to recover from a colony that has perished and provide instructions for how to use the remnants of the previous colony for instantiating a new one in the spring. Moving from mitigation of hives that have perished, the lesson to follow, this series will be an introduction to hive maladies. If you have questions, you can ask at our next online session. You can also send an email to the address on the slide. If you're watching from YouTube, you can leave a comment below. Thanks for watching. We'll see you at the next lesson.